Welcome to MH Math Facts. Today we're going to talk about polynomial long division. To start out, let's review just regular long division and just a few key terms that are really important. So when we're dividing, the number that we are dividing by, so in this case this 6, is called the divisor. The number that we are dividing is called the dividend. And so when we're setting up a long division problem, we're going to put the dividend inside of our little bar here and the divisor on the outside. Eventually, what's called the quotient, which is our answer, will go on top. Now for regular long division, we start with the very first digit in our dividend and say how many times is 6 going to go into 1? Well, it's not going to go in evenly, so we move on to the next digit. How many times is 6 going to go into 14? Well, it'll go in twice. So we write a 2 on top and say 2 times 6 is 12, and we write that underneath. 14 minus 12 is 2, and then we bring down our next digit, which is a 3. Now we need to figure out how many times 6 is going to go into 23. So we know 4 times 6 is 24, but that's too big. So it's going to go in 3 times. And 3 times 6 is 18. When we subtract that, we get 5. And we're going to write our remainder of 5 as a fraction. We're technically still needing to divide 5 by 6, so we write it as 23 and 5/6. So now let's try this with a polynomial long division problem. Polynomial long division is basically the same process as regular long division. It might feel a little different because we have variables involved. But we're going to set it up in the same way. So we start with the dividend inside and our divisor on the outside. Now one trick with setting up a polynomial long division is we need to have all the powers of x in descending order, and we need to have all of them there. So notice we have x cubed and we have x to the first power. We don't have an x to the second power term. And so we're going to write one in. And this is how we do that. 2x cubed plus 0x squared. Notice if we are multiplying something by 0, that's still just 0. All we're doing is adding 0, putting a placeholder in there so that our division is easier later on. And then plus 4x plus 1. Now to start out, it's very similar to regular long division. We look at our very first piece, and we look at our divisor in the very first piece of our divisor and say, how do I make this look like this? Well, x times 2x squared is going to give us 2x cubed. So we will put 2x squared right here. Now, if that wasn't easy to come up with right off the top of your head, you can always do a little division problem off in the corner. So we can say 2x cubed divided by x. So here, one of the x's will cancel. So that becomes a 2x squared over 1, which is just 2x squared. Okay, so now we multiply our whole divisor by 2x squared. 2x squared times x is 2x cubed. And then negative 2 times 2x squared is negative 4x squared. Now notice this is where our 0x squared comes in handy. We have our x cubed terms lined up and we have our x squared terms lined up. Okay, now this is a step where some people get confused. We want to subtract this whole thing. So I like to think of it as just switching the signs. So that becomes a minus, that becomes a plus, and now we just add straight down. These two are going to cancel each other out. Our 2x cubed minus 2x cubed is just 0. And then 0x squared plus 4x squared is going to give us 4x squared. Now we bring down our next term, which is 4x. And we kind of start the same process over. So we say, okay, how can I make x from right here look like 4x squared from right here? Well, I can do a division problem in the corner, 4x squared divided by x. One of the x's is going to cancel, so we'll be left with 4x. And so we'll put plus 4x right here. 4x times x is 4x squared. And then 4x times negative 2 is negative 8x. Now don't forget, we need to switch the signs. So that becomes a minus, that becomes a plus, and we add straight down. So our 4x squareds will cancel out. 4x plus 8x is going to give us 12x. And then we bring down our plus 1. All right, so now we do another round of this. X minus 2 is going to go into, or x goes into 12x 12 times. We just need to multiply it by 12. Again, if you want to, you can do a division problem off in the corner. No problem with that. And 12 times x is just 12x. And negative 2 times 12 is negative 24. And so now we just subtract, which means we're switching the signs. Our 12x's cancel out, and we're left with a 25. And that's our remainder. And we're going to write that as a fraction. So we'll write that as plus 25 over our divisor over x minus 2. Awesome, so we did it. This is our quotient right up here. But it's always a good idea to check. So the way that we'll do that, we're going to take what we had as our divisor, so x minus 2, and multiply that by our quotient that we got. So 2x squared plus 4x plus 12 plus 25 over x minus 2. So we're just going to distribute. So we'll do x minus 2 times 2x squared. So x times 2x squared will give us 2x cubed, and negative 2 times 2x squared is negative 4x squared. And so now we'll do that to the next term, to our 4x. X times 4x is 4x squared. Negative 2 times 4x is negative 8x. And then on to this 12, so we have 12x. Negative 2 times 12 is negative 24. And then we need to do x minus 2 times 25 over x minus 2. So because this x minus 2 will be multiplying in the numerator, actually let's just write that out. 25 times x minus 2 over x minus 2. Notice we have the same thing in both the numerator and the denominator, so those are going to cancel out. So we just end up with a plus 25 on the end. We can combine some like terms here. So this is the only x cubed term, so we have 2x cubed. We have a couple x squared terms, and they're going to actually cancel each other out. Minus 4 plus 4 will cancel out. This is our only x term, so we have minus 8x. Ooh, I think this was supposed to have an x in it, because 12 times x is 12x. So that's actually going to be minus or plus 4x. And then minus 24 plus 25 will be plus 1. And so is that what we started with? It sure is. So we're good. We did it. Feel free to leave any questions that you have about this in the comments, and we'll see you next time.